An object will be thrown from free fall. This object will be a tennis ball and a volleyball, from a height of 6 meters and 11.5 meters. Mass, gravity, air resistance constant, time, height, and velocity are considered in this project. The objective: solve the free fall example through the data, consistency, and mathematics models of the differential equations, and get the experimental height as much as close as the analytical solutions.
The schematic representation of the experiment: first we got the data, the height and the mass of the balls that would be thrown. Then we made experiments. We throw the balls in different heights and get the time with a timer. We measure this time. Then we solve the differential equation in paper, analytical, and then we plot the graphs, the analytical and the experimental ones. By trying to get the graphs together, we find the constant k by prove and fail. The solve of the differential equation. The net force is the second Newton law, F equals mg minus kb, where the derivative of b is dv over dt, and dv over dt plus k over m times b equals g, which is the differential equation of the system with the initial conditions t equals 0 and b equals 0. We can deduce that the solution for the velocity will be mg over k to the e. As the derivative of b, we got mg over k times 1 minus e to the minus kt over m times the derivative of t. With an initial condition x equals to 0 and t equals to 0, we got the position x. The analytical solution: as b equals dx over dt, we got dx equals mg over k times 1 minus e to the power of minus k times t over m times dt. With initial condition x equals 0 and times equals 0, the origin, we got that the position x equals mg over k times t plus m over k times e to the power of minus k t over m minus m over k.
We found the air resistance constant by trying and failing with different values. This was the characteristic part of the project, because to calculate this value of the coefficient we need a very complex formula related with humidity and other weather and time variables.
This is the graph of the height we calculate with a tennis ball that shows the analytical values with the key that we found, and the blue one is the graph with the experimental values that we got. The second graph shows the height that we calculate with the volleyball graph, the same as the past one, with the analytical values and the experimental values and the key dots.
As a conclusion, we observed through this experiment that we discovered a way to calculate the constant, which was the air resistance. We applied the free fall differential equation to find the solution to the velocity and the height.
This work shows us the free fall in analytical form and the role of the air resistance through the differential equations, and we model the equation of the free fall and find the constant of this equation.
We observed that it was difficult to calculate a solution to a differential equation with more than two variables and with the initial velocity and a constant, which was the reason we changed the experiment we proposed initially.